All right, today we're going to do worksheet 3. Specifically, we're looking at the first one, which we have to go back to one of our earlier worksheets and do balancing and do what type of reaction is it. So let's balance these. I see that I have 1 iron on the left, I've got 2 on the right, so I have to put a coefficient of 2 in front of the iron. And I've got 3 sulfurs on the right, so I have to put 3 on the left. So I am now balanced. Now what type of reaction is this? This is a direct combination. Or we could call it synthesis. We are producing 1 product on the right, so we know that it is synthesis. We can also tell, frankly, because we have 2 elements on the left, and that's pretty much all you can do with them is put them together. Right. How about gaseous methane with oxygen? Well, you should be able to tell immediately, because we're producing carbon dioxide and water, that this is a combustion reaction. So let's go and balance it. We have 1 carbon on both sides. We have 4 hydrogens on the left. We have to put a coefficient of 2 in front of our waters. Put a coefficient of 2 in front of our waters. That gives us 4 oxygens on the right. We have to have 4 oxygens on the left. So we are now balanced, and that's a combustion reaction. All right. How about copper chloride, lead nitrate, lead 2 nitrate? Okay. I have got 1 copper on both sides. I got 2 chlorines on both sides. I got 1 lead on both sides. I've got 2 nitrates on both sides. I am balanced already. Don't need to do anything to balance this. And what type of reaction do we have? Well, the copper and the lead are switching partners. So the copper is going to go with the nitrate, and the lead is going to go back with the chlorine. That is a perfect example of a double replacement reaction. All right, well, here we have an element and a compound becoming a compound and an element. That is a single replacement, traditional single replacement reaction. Let's see if we're balanced. Well, we have 2 chlorines on the left and only 1 on the right, so we have to put a 2 in front of there. So that means we have 2 sodiums, so that means we have to put a 2 in front of there. And we have 2 bromines already on both sides, so that's great. So we're now balanced. And we have a single replacement reaction. Let's look at number 5. Number 5, we're talking about solid silver and gold chloride, gold 3 chloride, and we notice that we have 1 silver on both sides, 1 gold on both sides. We have 3 chlorines here, which means we have to have 3 chlorines on the right, which means we have to have 3 silvers. So we are now balanced. And what type of reaction is this? Well, the silver and the gold are swapping. So the silver was alone. Remember, he came to the dance alone, so that's like being single. And he ended up leaving with chlorine, and now gold is single, so this is called a single replacement reaction. All right, gaseous ammonia is bubbled into water to form gaseous ammonium hydroxide. You'll notice you only have 1 thing on the right. So that means that this is a synthesis reaction, or a direct combination, call it what you will, whatever. All right. So let's look at what we have. We have to balance it. We have 1 nitrogen on both sides. We have 1 oxygen on both sides. And now we have these yucky hydrogens. 3 plus 2 is a total of 5. 4 plus 1 is a total of 5. So I am, in fact, balanced without putting in any coefficients. All right. Now for these last ones, all you had to do was figure out what reaction type they were. All right, so let's look at them. This one is starting with 1 reactant and becoming products, becoming 2 products. So this is decomposition. 1 thing becoming many. And here we have an element and a compound becoming an element and a compound. So this is single replacement. And over here we have methane gas with oxygen producing carbon dioxide and water. That is combustion. And we are also producing carbon dioxide and water again right here. So that is also combustion. Here you have a carbon, hydrogen, oxygen compound combining with oxygen. Our last one was just carbon and hydrogen, but that's okay. Either one is fine. Number 5, we're dealing with a synthesis reaction or a direct combination reaction, as we are with number 6, because they are both Sorry, can't write and talk at the same time because they're both only going to one product on the right-hand side. Right, number 7, clearly a synthesis reaction, producing one thing on the right. And number 8 has one thing on the left. So it is decomposition. And number 9 is producing one thing on the right. So it is synthesis. Right. Number 10. Number 10 is producing one thing on the right. It is synthesis. Number 11. One thing on the right. It's also synthesis or direct combination. Number 12. Ooh, this looks so messy. But really, it's not. Look at your two metals. All that's going on with your two metals is your two metals are swapping partners. So calcium is going over with carbonate, and sodium is going back with the acetate. So this is a double replacement reaction. It looks kind of overwhelming, but really it shouldn't be. Okay, what is this one? Well, the fact that you have 3 reactants might freak you out a little bit. But notice you only have one product on the right-hand side. Okay, so since it's iron 3 hydroxide on the right, that's the only thing you're producing. This is also a synthesis reaction, or a direct combination reaction, if you prefer. Right, number 14, I am producing one thing, which is sulfuric acid. So since I'm only producing one thing, that's a direct combination or a synthesis reaction. Number 15, same thing, I am producing copper 2 oxide, so that is a synthesis reaction or a direct combination reaction. And what have we here? Well, you look at this and you say, oh, this is really messy and I have no idea if it's an other. Well, actually, no, it's not. Remember, if we look at the waters, we call them 2HOH. And we're saying the H comes from one thing and the OH comes from another. Well, look what's happening. The magnesium and the hydrogen are switching places. So the magnesium is going with the chlorine, and the hydrogen is coming back and going with the OH to make HOH, which is H2O. This actually is a double replacement reaction. So pause the video, folks. Look at that one. Make sure you understand it. It's a little bit more tricky, but it is, in fact, a double replacement reaction. If you have any questions on any of these, please come see us. We'll be happy to help. And we'll see you sometime in class. All right? Have a great day, guys. Bye-bye.